Pulse Detonation and HHO, Part 1. Why Pulse Detonation Engines and HHO? HHO is a stoichiometric mixture, which means it has complete combustion as it is combined. HHO is in a volatile state, and all that's required to change the state from a gas to a liquid is either a spark or a flame. When you expose the HHO to a flame or a spark, you create the reaction which brings the HHO gas back into a liquid form with a violent explosion. This explosion converts the HHO back to water. HHO has a volumetric difference to water of approximately 1 water to 1750 of HHO gas. So that means when you explode or when your reaction takes place, you've come from 1750 millilitres or litres or whatever down to 1, which creates a vacuum. The idea of the PDE is to harness the detonation wave. The HHO detonation will exit the actual combustion chamber and exhaust tube at high speed, causing thrust. If the cycling time between pulses is correct, after the detonation of the HHO, the vacuum will then help to induce or pull in another charge of fuel of HHO for the next cycle. The cycle will be input, explosion, vacuum, input, explosion. My PDE has a one-way valve on the outlet to stop the reactive reverse thrust in a single cycle. This video is more about the HHO fuel production, my journey and my comments. Note, HHO is a very dangerous explosive gas, especially if handled incorrectly. Do not try any of this at home. My first cell was a simple stainless steel pads and stock cell, following the YouTube examples. One of the big problems with this system was sealing the wires and collection pipe. On YouTube, a lot of them say use a hot glue gun, but any movement breaks the seal. Tried a rubber sealant and had some success, but broke the sealant. I usually have 2 bubblers, a primary bubble and a secondary bubble for safety. This is what I end up going through to then. So this is a ball, which is a reservoir. The tap will be turned on, let the gas into the reservoir. Then the gas is turned off and pressurised. Open the second tap, pressurise the balloon, close that second tap. Now the balloon is isolated from the production side of it. I'm just going to use a balloon as a reservoir and as another safety device. To use the gas captured in the balloon, you crack the tap. Down the system here I have a homemade spark arrestor, which I have still yet to try, and a one-way check valve. It then goes in there into the solenoid valve. So that comes into here to a 12-volt solenoid, which is run by the Arduino, and the spark is controlled also by the Arduino. So we can time the amount of time that the solenoid valve is open and time when the spark is produced. I was able to get a small quantity of HHH gas into the balloon. Please see my previous videos and you'll see the 12-volt car fuel injector for liquid fuel. I could not get enough volume to use a 12-volt car injector. My next mistake was to try and inject the HHO from the balloon directly into the combustion chamber and add the timing spark. My balloon receiver was inflated to about 40 millimeters and got a flashback and exploded with an ear-ringing bang. Lesson 1, HHO is dangerous and every step needs to be thought thoroughly and analysed before you complete a step or move on to another step. I had used the recommended 20% by weight sodium hydroxide or caustic soda mixture for optimal performance. I then added the 12-volt solenoid for more volume of flow. I had some small detonations and could hear the air trying to suck back past my one-way valve. So I had partial success. I put a 12-volt amp meter in the circuit, but it was maxing out 60 amps, which is much too high. Therefore was only running the HHO generator for a short period of time. I purchased a pulse width modulation device and set the 12 volt input and 15 to 20 amps of current draw, but burnt that PWM out of a short period of time. Something was wrong. HHO generation is not as easy as it appears to on YouTube, some of the YouTube videos. I decided to upgrade the HHO unit. The second unit uses an undersink filter and has a 3/4 BSP outlets and inlets. I drilled the 3/4 inch cap to the size of the 2 wires and pushed the wires through the cap, then used araldite or epoxy resin on the inside to seal the 2 tubes. The reason I separated the wires, I had so much trouble trying to get air to seal between the dual wires originally. I sealed all the outlets with PTT tape or plumber's tape and added a pressure gauge. The pressure gauge is to check that it's not over pressurizing in the system. This cell is also a single cell unit using a piece of compression stocking and stainless steel scarapaos. Stainless steel wire attached on the inside would be a better alternative, but if you're using insulated wire, make sure you try to seal the ends to stop the capillary action of the fluid trying to run up the between the insulation and the wire and dripping out the end. After blowing up a second, a 60 amp PWM, I checked the resistance at 70 ohms on the meter. More research indicated a single cell only needed 1.5 to 2 volts. Over voltage creates wasted heat. Driving at 12 volts is overdriving my cell. I stopped using a 12 volt battery and set up an ATX power supply, which gives a 3.3 volt output, 5 volt output and 12 volt output. I discarded my original 20% electrolyte solutions and settled on 5 volts. Using a proven method, I added my distilled water, turned on my unit at 5 volts, and using the added power meter to check the amps, I targeted 16 amps. To be able to read down to 3.3 volts and 5 volts, you need to hook up your 12 volt supply to the auxiliary input. Put my distilled water in, turned on the unit and put in 1 teaspoon of NaHHO. Immediately got very close to my 16 amp current draw. So at 5 volts, 16 amps. Optimal 20% by weight was not suitable for my single cell. This is my PDE, which I will be testing. I've also modified my tip jet turbine with a spark plug and an injector. So I'll be able to put that solenoid onto here and turn this into a rotating engine. If you have a look at my previous videos, I was using a petrol or fuel to with compressed air to try to get detonations, and I was getting inconsistent detonations. So I didn't want to spend a lot of money on buying oxygen and that to try and see if that would make it work. So this HHO is the next step. The tip jet turbine was designed basically to test how much power was being outputted by the pulse jets using a generator and to see what power it would generate, with a small generator. By using HHO in the tip jet turbine, I can basically turn that into, I believe, a rotating detonation engine. Subscribe and to get part 2, which I will be testing the PDE and also the tip jet engine. I may update this video if I improve or make changes to the HHO to get better production, etc. Thanks for watching. Like and subscribe. Pulse Detonation and HHO Part 1.